Who's here watching the Euro tournament, the football Euro tournament? Who's here watching? Perfect. So the next lecture is way too long to read and way too difficult to read, so I won't read it. But WSC Sports, it's an Israeli company that combining the AI with sports. So it's going to be very interesting, especially for the people who watches the Euros right now. And I have the honor to invite Tamir from WSC Sports.
Hi everyone, I'm Bar. I'm an NLP algorithm developer at WSC Sports. And today we're going to talk about our AI sports commentator, which is a very interesting product and also a case study how we bridge the lack of domain expertise in LLM. So WSC Sports is a tech company that offers a wide range of AI solutions for sports media industry with the ability to create any kind of content anywhere, anytime, automatically in real time. We have 7 branches worldwide, more than 500 customers and 450 employees. Most of them are focused on R&D. And over the years, we won many innovation awards. And generally, WSC is considered the global leader for AI for sports media. And finally, our technology and AI solutions became an industry standard, such that among our customers, you will find the major leagues, teams, and broadcasters in the world. So today, we'll first go over the problem that we had to solve, then the challenges that we found along the way, and the solutions that we came up with. First, what is our problem? We are trying to generate a game recap that captures the best moments in the game, and then add to it a voiceover commentary. To better understand, let's see our example of a game recap that was fully generated by our AI system, including, of course, the commentary itself.
Game 3 of the series in Indiana. The Celtics lead 2-0 the series, and Tyrese Halliburton is out for the Pacers. Derek White with the dish to Tatum, who drives to the basket for the tough layup while drawing the foul. Boston extends their lead to 5.
Okay, so you see here an AI commentator that knows how to tell actually the story about the game. It first starts with some general context about the game, like that it was part of a series, playoff series, and that Boston already leads by 2 in the series. Then it continued to describe the plays in the game. We just heard about the first play and about the players that were involved, the actions like the pass, the shot, also the specific type of shot. It was the layup shot and not a dunk shot, for example, and also the foul that was happened there. And if we continue to the end of this recap,
in a thrilling contest, the Boston Celtics complete an impressive comeback in the fourth quarter to secure a hard-fought victory, 114-111 over the Indiana Pacers to lead the series 3-0. They'll be back in Indiana for Game 4 on Monday.
So it also knows how to summarize the game in a more higher-level perspective of the game. It knows that it was a comeback game, that Boston came back to take the lead, to take the win, and now lead the series by 3 already. So to make such a game recap is not a trivial task, and we can divide it into 3 main parts. First, we need to select the best moments of the game, the highlights of the game. And then we need to think, what is the story we want to tell about the game, and write a script for the commentary. And finally, taking this script and make it into a voiceover. So when video editors do it in manually, all this process can take sometimes few hours even for 1 game recap. And we in WSC automate all these parts and add also a translation module that allows also content localization. And today specifically, we will focus on the recap script writing part. So what is the input to our problem? We have the sequence of best events that we chose in the previous part, and each one of them comes with some metadata like you can see here, the teams, the player, the action, etc. And the output, again, we are trying to generate a script to commentary. So what are the challenges that we had? We say that we have now already all the metadata for all the selected plays. Now let's assume we work in an in-context learning approach. So theoretically, we can take all this metadata, give it to the LLM, maybe with one or more few shots, and ask the LLM to generate a script for us. Sounds pretty easy, so let's try it out together and see what happens. This is actually an output of this kind of naive use of LLM for this task.
11:37 in the quarter, Doncic, the second-year sensation with the steal and the fadeaway, takes his team to a big lead.
Okay, so this experiment was actually failed. Let's see why. So first, Doncic he's the biggest star of his team, Dallas, and the LLM calls him the second-year sensation. But unfortunately, it's already his 5th year in the team. So probably the LLM uses some outdated knowledge. Then it hallucinates an action that have never happened there, the steal of the ball. And also it thinks that 2-0 is a big lead, which maybe in soccer it is, but in basketball it's definitely not. So probably the model understands basketball as much as I understood basketball before I joined WSC, which is not so much. And finally, you could hear that the commentary is very with a lot of excitement, right? Which is really not relevant in it's just the first moments in the game. Like it's 2-0, no reason for such excitement. So how can we overcome all these challenges? Let's see how our system looks like. We have now 3 main parts. The storyline sports composer, which determines what to say and when to say during the recap. Then we have the dynamic prompt module that dynamically generates specific instructions for each specific play. And finally, we have the grounding chain of thought module that factually verifies the output of the LLM. We'll focus now and go over briefly on these 2. First, the dynamic prompt module. It contains first the system prompt, like usual, for some general context and general instructions. Then the play details part and the dynamic few shots part. As to the play details, we first give them in a very structured way. This allows us later to relate to specific parts in our prompt. So we will use it later in the grounding part that I will elaborate in a minute. And also if you want to add now a specific instruction, like in this play, you have to mention the time in game. So the model can easily go to the time in game part in the prompt and integrate it into the output. Then we are really adapting also the information in the prompt because we cannot assume that the model really understands basketball. So for example, we will not give the clock time as is, but we will digest it for the model. Like we'll say it's 11:37 and it's actually the beginning of the game and the beginning of the quarter. And also we will add another instruction like don't mention the score of the game here because it's just the beginning of the game and it's not interesting that it's 2-0 now. Also, another example, we all know that LLMs, right, have some arithmetic issues. In our case, it comes in the score part. So when we say 2-0, we sometimes don't really understand what's the meaning of the 2-0. So we add also that explicitly, Dallas leads by 2 now. And before that, it was 0-0. So what happens is actually Dallas took the lead. Like we are really digesting the information with our understanding of basketball. So that was the dynamic, play details part where we already encoded some domain expertise. Now we want also to control the style of the output. And what do I mean by controlling the style of the output? let's say now that we have a very big moment in the game, like huge comeback or a big momentum change that happened. So we want also the commentary to be very excited, right? So in this case, we will also choose more excited few shots. And vice versa if it's just the beginning of the game. We want more quiet commentary, and we'll choose more quiet few shots. So that's why we select the few shots according to the specific properties of the play we are looking at now. Okay, so this was the dynamic prompt module that allowed us to encode some domain expertise, as I said. And now let's move to the grounding chain of thought module. So we want also to reduce the number of hallucinations and the influence of irrelevant knowledge of the model. So inspired by the chain of thought work and chain of verification work, we came up with the idea of taking the output of the LLM and ground all the parts of the output to the play details we give as input. And the technique looks like that. We have from the left the first call to the LLM, like we've seen till now, where we give the play details as input, and then the LLM generates a baseline script as output. And then we have another call to the LLM. But now, in addition to the play details, we give also the baseline script as input. And the task of the LLM will be to first recognize all the parts in the baseline script that are not aligned with the play details. After it recognizes all these unaligned parts, it regenerates the script, as you can see in the right part. But now it will exclude all these recognized ungrounded parts. So to better understand, let's see it in example. We have the same play details and the same bad baseline script that we saw in the beginning. Now we have another call to the LLM, and the LLM recognizes all the ungrounded parts from the baseline script that are not aligned to the play details. Like, do you remember the steal that have never happened? So the LLM recognizes that in the play action, there is no steal, but only 2 pointers. So now it will regenerate the script, and we have and actually will erase all these ungrounded parts that it was recognized. And in the new script, we have no hallucinations and no influence of irrelevant knowledge of the LLM. So to recap this recap journey, we had a structured adapted prompt and dynamic few shots that allowed us to both encode some domain expertise and control the style of the output. Then we had a grounding chain of thought module that allowed us to factually verify the output of the LLM. So this project is already in production and actually used by the NBA, mainly in Spanish. You can hear Spanish commentary game recaps in the NBA app. But it can also go to many other different interesting directions. Let's see what we can get if we add a little bit more spice into it.
It was the World Cup Finals, Argentina and France. 8,966 fans in the stands, the tension intense. He moved was fouled, the penalty for Argentina. Messi steps up and scores with finesse. The France won't give up, they fight till the end. 2 substitutions at halftime, they're ready to defend. They finally break through, a penalty they won. The Pap takes the shot and the score starts to turn. But Argentina won't back down, they fight till the end. Messi scores again, his talent.
Okay, so many other interesting directions. Thank you for your attention.
Thank you very much. I'm Tal. Very impressive work. I'm wondering if you can go a little bit more deeply into how you address the hallucinations in a general setting and what the kind of false positive situation may be if a hallucination does occur in a production system.
So,
Does that
okay.
make sense?
So you want me to repeat the hallucination? How we?
No, just more in a more. You gave a specific example, I think. So can you address how this applies more generally? Does that make sense? Or
Sorry, I didn't get you. How we address
the hallucination issue, but in a more general way, if that makes sense. If not, we can
in
take it
more
offline.
general way than what we do here. So,
If not, if it's okay.
like first already, like when we dynamically select a few shots according to the play details. So if we are trying to actually very match it. So if we have now a 3-pointer in from like half of the court and like in the very end of the game, so it's a very like thrilling moment. So also the few shots will be from the same moment. So this already like reduce some hallucinations because we will not have other actions that comes in the prompt, etc. And like actually this grounding chain of thought part already like reduces almost all the hallucinations. Like we always have where to get progress, but it works really, really fine. We still like checking it and trying to do better.
I also have a question, if I may. By the way, it was really interesting. What are the challenges that you have when you're taking those commentaries to voiceover? You know, what are the challenges that you have when you take those commentary scripts into voiceover in the videos?
Okay, so I actually focus now in the script writing, but then after we make the script, we have the other part of taking it into a voiceover, and then there are many other challenges like. We first need to sync with the video. Like we cannot have too long commentary where the video of the specific plays is very short and vice versa. Also, the pronunciation of the players. You heard a bad pronunciation of Doncic, for example, in the challenges, and so there are many European players that. The speech-to-text model cannot like pronounce well, actually, and also like we have So for example, the pronunciation we are actually giving for the players the phonetic form, the phonetic way to say the name, and it helps the model to better understand. And also, we actually adapt the length of the script to the length of the video of each play, and that's are the main challenges there.
Perfect. So now you like basketball?
Sorry.
So now you like basketball after you work in WSC Sports?
Yeah, I always liked basketball, but it was too short in order to play it a lot. So
last question, please, guys. Sorry, we don't have time. Thank you so much for Tamir from WSC Sports.